All right, in this lesson we're going to go back to chapter 1, and it's something that we skipped for about limits, but it shows up in calculus classes, so this will help you prepare for that. And let's start with this graph, and we have this Greek letter epsilon and this Greek letter delta. If we look at this graph, we want to be thinking of the answer to this question, which is if you choose for this epsilon, epsilon is a distance away from 5 on the y-axis, and delta is the distance away from 4 on the x-axis. We can go up delta or down delta, and this is up epsilon, down epsilon. And for this epsilon that I've drawn, is delta small enough so that if you pick any x value in here that's within delta, so we're going to go up some number that's not equal to delta, we're going to go up less than delta. If we choose an x value right there, will its y value be less than epsilon away from 5? So we want to be thinking of that question. For every x that is within delta of 4, will f of x be within epsilon of 5? So in this graph, the answer is yes. And now we look over here, and so here we've chosen an epsilon, and will every x that is within delta of 4 be within epsilon of 5? So look for x values that will have y values that are beyond epsilon, and that's going to happen right here, where the y value goes beyond epsilon away from 5. So epsilon creates this interval on the y, creates a y interval that every x value that we choose needs to have a y value within that interval. And these even go over here, and we could also say that there are x values that are within delta of 4 whose y value is not within epsilon of 5. It goes beyond that interval. Now, if we chose delta to be smaller, then we could say that maybe if delta was right there, delta, we went up that amount and down that amount, then we could say every x value within delta, within this delta, is going to be within epsilon of 5. And that's getting that's moving towards the definition of a limit. We're going to choose an epsilon, or for each epsilon that we could choose, there is a delta that's small enough so that every x value within delta is within epsilon of 5 of the y value. And here we have another example. Here we have a different graph, and here's the x value and the y value. We've chosen an epsilon, and then we've chosen the delta. For this epsilon, we've chosen this delta, and is every x value within this interval going to have a y value within epsilon of 5? And we could just draw the dotted lines for the epsilon, and we want to look for is there an x value between these 2 points that has a y value beyond this interval? And we'd say yes. Right here there's a x value within delta of 4 that has an y value beyond epsilon, or not within epsilon of 5. We have to go beyond epsilon. And it also happens in here where we could choose this x value, and that y value would go beyond epsilon, away from 5. So then you choose, draw this graph, and choose a delta that would have all the x values less than within delta of 4 will have y values within epsilon of 5. So pause the video, draw that. And if we just looked at epsilon, and that establishes that interval, we could say that if we move up delta, so there's 4 plus delta, and here's 4 minus delta, that every x value within delta of 4 will have a y value within epsilon of 5. And those concepts are what are used in this definition of a limit. So here's the statement. The limit of f as x goes to c equals L means that for each epsilon, each possible epsilon that you could choose that's greater than 0, there exists some delta. That means for every epsilon, you would choose a delta such that if the distance of the point that you're at away from C is less than delta, that means if the x value is within delta, then the y value is within epsilon of L. So this is the way we would write out those things that we've been talking about up here. And if we looked at, so here C corresponds to 4 in the example we did. X corresponds to all the possible points we could choose between that are within delta of 4. And delta and epsilon are the same. Now, f of x corresponds to, L corresponds to 5, and then f of x corresponds to all the y values that we would find choosing any x value within delta. And here is how the proofs go. We must show that for each epsilon greater than 0, there is a delta greater than 0 such that if x minus 3 is less than delta, then 4x minus 5, the function, minus 7, which is the limit, is less than epsilon. For each epsilon, we need to choose a delta. So the work is in finding the delta. So we have a preliminary step. Step 1 is where we always can start like this. If 0 is less than x minus 3 less than delta, then oops. And here we get 4x minus 12. And we can do this, take a 4 out, x minus 3. And now we have epsilon over 4. All right, and so this tells us that we want to choose delta equal to epsilon over 4. And this is all the preparation, and now we just state the formula, state the theorem or definition. So now we just restate what was given. Given epsilon greater than 0, choose delta equal to epsilon over 4. If 0 is less than x minus 3 is less than delta, then 4x minus 5 minus 7 equals 4x minus 12 equals 4x minus 3 is less than. Now we see the connection. This is less than delta, so this is less than 4 delta. All we do is substitute for the absolute value of x minus 3, and that means that 4 delta can be replaced by 4 epsilon over 4, which equals epsilon. And this is how we can satisfy the proof, satisfy the definition, where by choosing a delta, we have shown that f of x minus L is less than epsilon. And that was what we looked at over here. For each epsilon greater than 0, there exists delta such that, and we have to show that for the delta that we choose, this is true. F of x minus the limit is less than epsilon, and then that's what we've shown here. Because delta is chosen to be epsilon over 4, it allows us to do this substitution here. It allows us to do that, which then ends this statement with an epsilon, and that satisfies the definition. Okay, try that with this problem. Pause the video. And so we must show that for each epsilon greater than 0, there is delta greater than 0 such that if, here's step 1, I didn't write that first sentence, if 0 is less than x minus 4 absolute value less than delta, then f of x minus L is less than epsilon. Alright, and that's how we choose delta. So let's choose delta to be epsilon over 2, and now we can just state the definition. And we start by writing given an epsilon greater than 0. Choose delta equal to epsilon over 2 if the x value is within delta. If the x value is within delta of 4, then f of x minus L which equals 2x minus 8, which equals 2 times x minus 4. X minus 4 is less than delta, so this is less than 2 delta. And we chose delta to be epsilon over 2, and now we've satisfied the definition by saying that given an epsilon greater than 0, we chose a delta that makes f of x minus L less than epsilon. And then, since we're writing a proof, we want to state what we've proven. And the these limits are really basic, but we're just learning the steps of the proof. All right, pause the video and try that one. So our preparation is if 0 is less than x minus 3, we choose that number, is less than delta, then f of x minus L is less than epsilon, and we can take a 1/5 out. X minus 3 is less than epsilon. X minus 3 is less than 5 epsilon. And we choose delta equal to 5 epsilon. Then we can make this statement: given epsilon greater than 0, choose delta equal to 5 epsilon. If 0 is less than x minus 3 is less than delta, then f of x minus L which equals 1/5 x minus 3, and we know that x minus 3 is less than delta, so that means this is less than 1/5, less than 1/5 delta, and then we can substitute for delta, and now we've shown that there is a delta, here's a delta, that is small enough so that f of x minus L is less than epsilon every time we choose delta equal to 5 epsilon. And prove that. Oh, and we would also say, therefore, the limit is 3/5 up on the previous one. Okay, pause the video and try that one. So we start by saying if 0 is less than x minus 6 is less than delta, then f of x minus L is less than epsilon. And here we'll have to combine. This is a 6 over 2 minus 9 over 2, so we get, oh, let's make it a 4. So let's go x over 4 plus 12 over 4 minus 18 over 4. 12 minus 18 is 6, and we can put a 1/4 on the outside. 1/4 x minus 6 x minus 6 less than 4 epsilon, and that means we choose delta to be 4 epsilon, and then we can state the definition. Given epsilon greater than 0, choose delta equal to 4 epsilon if x minus 6 is less than delta, then f of x minus L, which equals x minus 6, 1/4 x minus 6, and x minus 6 is less than delta. Oh, I forgot to put the 0 here. And that will be less than 1/4 delta, because x minus 6 is less than delta, and then delta is for epsilon, which equals epsilon. Alright, and we'll stop there.